The next book is Electromagnetics, History, Theory and Applications by Robert Elliott. The book is a pretty old book, but still very, very good. It starts off with the phenomenon of light. It goes straight into special theory of relativity before it moves into electrostatics in free space, magnetostatics in free space, electromagnetics in free space, dielectric materials and magnetic materials, and then conductive materials, and some very interesting appendices and mathematical supplements. So this book combines a lot of very fun historical notes. Like the very first chapter is all about what people thought about light, what the Greeks thought about light, what the Arabs thought about light, the velocity of light, the nature of light. And then it just basically moves on from there. It does everything based on special relativity, which I think is the best way to do this kind of stuff. And yeah, it just does electromagnetism, I think, the right way. I'm currently doing this book with Brouwer, and I'm reading through it as well. And while the math is sometimes pretty brief, and maybe a bit too brief, I think the physics is made in a way that I think I really like. So yeah, definitely highly recommend it. Alternative to a book like Purcell, I think is very plausible. The next book is Fluid Dynamics, Theory, Computation and Numerical Simulation by Potrikidis. And yeah, it's basically a very giant book on fluid dynamics. So it starts off with kinematics, more kinematics, flow computation based on kinematics, forces and stresses, hydrostatics, equation of motion and vorticity transport, channels, tube and film flow, finite difference methods, low Reynolds number flow, high Reynolds number flow, vortex motion, and finally aerodynamics. So what I like about this book is that it combines a lot of numerical methods, ways of computing things, of simulating fluids and so on, together with a very nicely laid out theory. So yeah, it does both the theory very well, and it also does the computations very well. So yeah, it's a perfect book if you really want to learn how to compute certain stuff, as opposed, yeah, to just learning the theory. There are probably not as many exercises as I would have desired, but yeah, I think it's a pretty minor point, because I do really like this book a lot. The next book is The Complete Vegetarian Kitchen, a book in Dutch by Rose Elliott. And yeah, it's basically a book on cooking vegetarian dishes. Haven't really used this one too much, but they look good, I guess. Then we have this book, Pink Floyd Completes, the story of the 179 songs. It's basically covers the different songs and the background and production and a lot of things to know about the song. So yeah, extremely good book. If you're like me and you're really a Pink Floyd fan, you will absolutely love this book. So yeah, highly recommend it. Next up, we have Foundations of Modern Physics by Steven Weinberg. So yeah, it's a pretty high level view of physics. So it starts with early atomic theory, thermodynamics and kinetic theory, early quantum mechanics, relativity, quantum mechanics, nuclear physics, quantum field theory, and that's where it ends. So it's a pretty high level view of physics and how physics is done and how physics should be done. I haven't really read this book yet, so I can't comment too much. Next up, we have a book that I use a lot on the server. We have Hodges, Kiswell and Hodges, Mathematical Logic. So it starts with natural deduction, propositional logic, quantifier-free logic, and finally first order logic. So the book is pretty nice and pretty in-depth. So it starts off with doing all the different logical deduction rules in classical logic, and deriving a lot of consequences that we may take for granted in books like Vellman. Then it goes on and really builds first order logic, first propositional logic, then quantifier-free logic, then quantifier logic, and it really builds those up from scratch, giving a lot of details, and eventually leaves off with proving the sound and completeness theorems, which is a major accomplishment. So yeah, I think it's my favorite logic book to do with people or to start with people. So definitely something I would like to do with a lot with more people, because I think the book is really, really well done. Here we have Logic for Computer Science by Van Bentham, Ditmars, Ketting, Lodder, and Meyer-Veal. It's the book I used at university. So it does propositional logic, does predicate logic, logic and programming, logic and artificial intelligence. So I basically had to buy this book for my undergrads, because this is the book that we learned from. Didn't really use it too much though, but yeah, does look like a solid book. It's just that it's in Dutch, so yeah. Next we have here Inversive Geometry by Morley and Morley. So it deals with the geometry of inversions in a circle. So we have operations on elementary geometry, algebra, Euclidean group, inversions, quadratics, the inversive group of the plane, and finite inversive groups. Then it goes on to parabolic, hyperbolic, and elliptic geometries, celestial sphere, flow, differential geometry, line and circle, regular polytopes, motion, triangle, invariant Sonor homologies, rational curves, conics, cardioid and the deltoid, Cremona transformations, the n-line, and that's basically it. So yeah, if somebody is into classical geometries and classical constructions and basically everything that's beautiful about it, definitely some book that I would recommend. Not many people are too into in this kind of thing nowadays, but yeah, it's what it is. I do think it's a very nice book, very nice written book. But yes, you can see it's quite old style. Next we have here a book by Raymond Smullyan, First Order Logic. So Smullyan is an author known primarily for puzzle books, but this is not a puzzle book. It's an actual rigorous book on first order logic. So it does analytic tableau, compactness, first order logic preliminaries, analytic tableau, unifying principle, fundamental theorem of quantification theory, axiom system for quantification theory, magic sets, analytic versus synthetic consistency properties, Gensen systems, elimination theorems, Preenix tableaus, more on Gensen systems, Craig's interpolation lemma, and Beth's definability theorem, symmetric completeness theorems, and systems of linear reasoning. So yeah, basically all about first order logic and about exactly how they are done. Pretty nicely done. Yeah, definitely. If you're into logic, maybe you like this book as well. Next, we have here the book Galois Theory Through Exercises by Brzezinski. So yeah, it's an exercise-based book leading you to Galois theory. So it starts with solving algebraic equations, field extensions, polynomials and irreducibility, algebraic extensions, splitting fields, automorphism groups of fields, normal extensions, separable extensions, Galois extensions, cyclotomic extensions, Galois modules, solvable groups, solvability of equations, geometric constructions, computing Galois groups, and yeah, then the proofs and hints and answers and examples and selected solutions, and then some appendix. So yeah, basically a lot of exercises. I just think there may be a bit too many computational exercises. It isn't really. It's based on a lot of examples, that's for sure, but they're mostly like computational examples, as opposed to really theory based, which is what I would have preferred. Next, you have here Burn, a pathway into number theory, an exercise-based book towards number theory. So we see here the fundamental theorem of arithmetic, modular addition and Euler's phi function, modular multiplication, quadratic residues, the equation x to the n plus y to the n is equal to z to the n, sums of squares, partitions, quadratic forms, geometry of numbers, continued fractions, and approximation of irrationals by rationals. So yeah, it's basically, it starts with exercises. So it starts with, it's basically a series of exercises going through a lot of number theory. They start off, every exercise is pretty easy. So every exercise follows from the previous one pretty trivially, but it does end up in quite some, quite some deep stuff, number theoretically. So yeah, definitely something that I might see myself doing with people who are exercise based and maybe are not that good in proofs yet. I'm not sure if Crimson would enjoy doing this book. I think he's too good for this book. But I don't know, maybe he likes the exercise based approach like this. I don't know. And then we have here Introduction to Evolutionary Computing by Iben and Schmidt. So we have problems to be solved, evolutionary computing, the origins, what is an evolutionary algorithm, representation, mutation and recombination, fitness, selection and population management, popular evolutionary algorithm variants, parameters and parameter tuning, parameter control, working with evolutionary algorithms, and then some advanced topics. So this is all about using evolution as a model for algorithms and making sure that you get your optimal answer based on an algorithm that is made with evolution. I had to get this book for a class, but look, it uses Lisp. It's okay.